Number one, for something to be completely transparent, that means, by definition, that its opacity is zero. Transparent and opacity are opposites. If something's filled with white, it is not transparent. It would block out anything that's behind it, like a background. An opacity of 45 is not completely anything. It's in the middle between 0 and 100. And opacity 100 is the exact opposite of being completely transparent. So the answer is definitely A. You can test this by putting this code into the editor. And here's an example of a transparent, here's the answer A. You'll see here as output. You do not see a black rectangle because its opacity is 0. If I change it there to 100, then you will see the rectangle, but with opacity of 0, you will not. Moving on. Exercise number 2. The answer is B, the leftmost point of the following shape. An oval's center is defined by the first two arguments. 150 is the x, and y is the second 150. That third value in the parentheses is the width of the oval, and that fourth one is the height. Now, if the full width is 200, then from the center out to the left, that would be half the 200. 200 divided by 2 is a distance of 100. And this original 150 minus 100 is equal to 50. So this left edge would have to be at the point x equals 50. In the same way, you can compute the top edge. Well, it doesn't matter. We only are concerned with the leftmost point, which would be this point out here at the tip. In a Python editor, you can see here that with this exercise 2, this left edge here of this oval is, you can tell it's about 50, the leftmost point, because the center here is at the point x equals 150. Okay, moving on to exercise 3 on the practice midterm. Which of the following is the result of this code? Well, this first rectangle is in the background, and its color is black by default. So C would not be an answer because in C, the black rectangle, which is really a square, but still it's a rectangle, it's in front of this other white shape. And in the case of D, you have the border of this one above this one, which actually is okay. So moving on. When you look at the second line of code, now that we've ruled out C as an answer, you see that you have basically a white rectangle below. Well, this code is below the first line of code, but because code that falls after another line of code, it appears stacked on top of whatever was before it. So this top rectangle here does have a fill of white. This one over here does not. It looks like it's transparent, it's hollow. It does not, it's see-through. So it does not have a solid fill white. And answer B, there is only one rectangle there. And there is no rectangle that has a border anyway, even if it were invisible in some way. So B is is out because there's only one rectangle. The answer is A. The white rectangle is on top of the black rectangle because the order of the code. And you see here in the sandbox where I have an example of exercise 3. And here you go. That is the answer A from the practice midterm. Exercise B. It is not legal. It is illegal. Therefore, the answer is not D, because if a variable name begins with a digit, you cannot begin with a digit. You can have a digit later in the name, like box 1. That would be legal, but not when you have the digit 1 at the very beginning. So D's out. C is not legal because of that space. You can't have spaces in variable names. It would cause an error, a syntax error. A is not legal because rect is a shape command in Carnegie Mellon CS Academy. So because that's a command, you cannot name a variable after, with that same spelling. You could name it rectangle, spelled out as a whole word, but you cannot use RECT since that is a reserved command. Box is a perfectly good legal name for a variable. It's the answer to exercise 4. Over here, you can play around with this. I have box equals 1, that works. But if I tried to use a variable named RECT, we're going to see here that we actually can, but it's bad style. So be sure to choose the best answer that's available. In this case, box is a better variable name. Number 5, the answer is D. Which of the following are parameters of the function? Well, parameters are the variable names that are used in the parentheses of a function definition. So color and label size are parameters. Arguments are not found in a DEF line of code. These are not arguments. Arguments are found in a call. And the call here, the line of code that's indented, this label command, technically hello is an argument, so is 200, so is that 200, but they are not parameters. So there are indeed arguments, but there are also parameters in this problem, so the answer is not C. And you could sort of like use a process of elimination to rule out both A and B, because A is color and B is label size. Well, they're both kind of equals being used in the parentheses, whereas the answer D is both of them. So it would make sense that color is an argument, but label size is not, or vice versa. So a logical answer, even if you were unsure of this test question, would be the answer to go with the answer D rather than A and B. Moving on to number 6. This is tricky because each time the draw shape command call executes, 2 shapes are drawn. So when this first line of code executes, in the function definition, there will be 2 stars. The one star is smaller than the other one and a different color. Well, it's like I said, it's smaller. The radius is smaller. And then when the other call executes, two more stars are drawn. That's 2 plus 2, which is equal to 4. The answer is D. You can see that here in this example. If you play with this code or retype it, you can see that there will be, because of that exercise, there are stars on top of stars, but a total of 4 stars. 4 polygons, I should say. 4 polygons. Okay, moving on. Let's comment out some of this code so that we can use it later. And the next exercise, number 7. A global variable according to our guidelines in class. Well, syntax guidelines mean that a variable name is legal and it has good style. The coding style that we use in this class. You should not name a variable a rectangle, even though we saw earlier it is legal, it is bad style. So just to be a little bit clear here, at least on this version of the practice test, practice midterm until it might be changed. This technically is legal, but it's not good style. Down here in the exercise that we're currently reviewing, definitely rectangle is not good style, and so therefore I would say it incorrectly defines a global variable according to our syntax guidelines. Now the word square is fine. The letter S, even though it's only 1 letter long, it's not the best. And C, it's not the best name. But a rectangle definitely is bad. Number 8, when the mouse is pressed at the location roughly 300 on the x-axis and the point 100 on the y-axis, at that point, the 300 is less than, it's greater than the 300 plugs in there for x, and that is indeed greater than 100. So this if statement is true. Because it's true, you will see a rectangle. If, for example, you clicked the point at the location 0, 0 here in the upper left corner, 0 is not greater than 0. So that would be a false in this if statement. If you clicked at this point 100, 300, that would be at approximately this point right here. And the first parameter, that 100, would plug in for mouse X. So again, let me repeat. If that first 100 were the first argument there, it would plug in for the parameter mouse X. And then this 300 would plug in for the mouse Y, because the order is important. The 100 comes before the 300. Therefore, this mouse X is really the value 100. This mouse Y is really the value 300. And when the computer executes this line of this if statement, that first number, the X, plugs in there. And the second value for mouse Y plugs in here. And 100 is not greater than 300. And because that's false, you would not produce a rectangle. You do not execute the body of an if statement if it's false. So you can also analyze then option A, Option A is where the two parameters are, the two arguments are 200, 200. That would be roughly exactly a click in the center. And 200 is not strictly greater than 200. That's false as well. If it were a greater than or equal to symbol, it would be true, but it's not. So D in this upper corner, anywhere in this upper quadrant, if you click anywhere up there, you will see a rectangle. And we can see that by playing around with this program right here. I might not have that one typed into the example. Yep, here it is. So right now when I run this, if I click up here, I do get a rectangle. But if I click down here, say in the lower left, I do not. In the upper left, I clicked basically anywhere above this diagonal. It's not just the upper quadrant. It's anywhere in the top right triangle, if you will. See, I'm clicking, those are all spots where the X is greater than the Y. Down here, I'm clicking and I'm getting no squares, no rectangles. Okay, moving on to the next exercise. Number 9. This is simply the not equal to symbol in Python when you're using if statements. So if you have something like if num not equal to say 2, that would not work, because in math class that might be the not equal to symbol, but it does not work in Python or any computer language. Instead, the not equal to symbol, the not equal to operator, it's typed as an exclamation mark followed by an equals. It is not typed this way. It is not typed that way, like we said, and it is definitely not typed that way. That has nothing to do with not equals. The plus equals is just something else in Python. Next, number 10, code will always run in either the if or the else, but not both. That is just the way it works with if-else statements. When you have code indented with the if and you have code indented with the else, it all hinges on whether it's true or false. If it's true, if this Boolean expression is true, then you do that part and you do not execute what's in the else. But it's just the fact of how it works. If you have a false, if the false is the Boolean expression's value, well, then you do not execute the if. Instead, you do indeed execute whatever's down here in the else. So that's just the way it works. And you can see that in this code segment here, where I have num is equal to 1, and we will see no matter what value I substitute in there for num, down here we'll either get the output this or the output but not this. We will not get both answers. So in this case, when I run the program, we see the phrase but not this, and we do not see just the print statement output from this. Exercise 11. A helper function, if you study chapter 3, is not something, it is not something, this is not true, be sure that you saw the word not there. It is not something that is tied to a user's action, like a click of the mouse or a press of a key. So a helper function is typically something that, as you read in as you studied in chapter 3, It's something where you might name it draw background, but it's not something that happens when the person clicks. So right now, when I call that function, example helper, I will see the message, this worked without a user event. When I run the program, it just happens down here. You see that print statement. When I run the program, it happens even before I click the mouse or I press any key on the keyboard. So a helper function is one that's just used to organize code, usually, to help you program organize your code. And exercise number 12. This is an example of an if, elif, else statement. And the prompt suggests that the value of num is equal to 12. So that would be similar to you seeing the line of code num equals 12 right before this if statement. And it trickles down like a waterfall. That 12 is substituted in for the variable num, and you then must evaluate and ask yourself, is 12 less than 12? That's false. So because it's false, you skip, you do not execute that indented clause, that body, and you trickle down now and you plug in the value 12 for num there. Now in this case, we have a greater than or equal to symbol. So you must decide if this is true or false. In math class, it would be represented that way with a greater than or equal to symbol. But here in Python, we separate those two operators, but join them with no space in between. And 12 is indeed equal to 12, so therefore this is true. And we do actually then draw the circle. And that's why the answer is B. And then you skip out of the if, elif, else statement. As soon as you get a true, you do not execute any more of the code in a conditional branching statement like that. And you can play with the example that you see over here in this sandbox demo if you have access to it. Here I have this code segment, and you can try different numbers there for num. And when you run it, you'll see either not this. In this case, I got a not this, but it did not execute anything else in the bodies. I can change that to the value. In exercise 13. Okay, we're doing exercise 12. In exercise 12 up here, well, my code doesn't match the code. I have different examples blended together, but you can play with this code to just be sure that you understand how an if, elif, else statement works overall. And last of all, number 14. Which shape will be in front if num is equal to 5? So you're supposed to execute this code as if the line of code num equals 5 is given to you. Therefore, in place of the variable num there, you would put a 5. And 5 is indeed less than or equal to 5. That's true. So the R2 front executes. This rectangle, which is black by the way, will come forward. And even if the circle and the star were originally on top, oops, wrong color. Even if they were on top of the rectangle when they were drawn, so even if they were layered like this, the rectangle, which technically would be black, this black rectangle will end up being the item that's on top. And in this case, the black rectangle is the whole canvas. It's the whole canvas from the point 0, 0, and down here to 400, 400. It fills in the whole thing in black. So it's completely on top of the circle and the star because of the to front function or method. Here's an example of that exercise. Number 14. And you'll see that the whole screen turns black. If num were not 5, if it were, say, 15, well, then it's a different story. Then something else, in this case, the circle, would be on top. And you can play with those different numbers. And of course, to front and to back can be studied in your notes. This is all material from Unit 4. Good luck.